Good morning, students. So, the detail of the complex structural element. It is a problematic subject. So, we are going to explain the structural element. Already, in first, we explain about what is structure and what is the concrete, how we are preparing this, and what is preparing for concrete. Okay. So, here in this, so this is the syllabus. Again, you can see the syllabus. Their syllabus is design all the structural elements used in building. Now, if you learn this subject, what is the course outcome? Here you can see the course outcome. First, if you go one, so here you can see the five course outcomes. That means each unit has each course outcome. So, your first unit, CO1, if you study this unit, the outcome will be know the various design of concepts and design RC rectangular beams by working set method and state method. CO2 the design of planned beams and design for shear, torsion, anchorage, and length. While we are using the shear reinforcement and torsion reinforcement, what is the purpose of using torsion and shear, and how we need to design the shear reinforcement. And the third unit is design of slabs and staircase. So if you study this, what is the outcome means can able to design the different types of slabs, that means one-way slabs and two-way slabs, and the staircase, you know what are the types of staircase, dog legs, bifurcated, spiral staircase, like that. So here we are going to design the dog-legged staircase. And the design of fourth unit, the fourth outcome is design short columns for axial, uniaxial, and biaxial and eccentric loading. Column is very important structural. So there are different types of columns. Already in strength of materials, we studied, I think, Euler's formula, we using formula, and classify the columns based on the slenderness ratio. We will use the Euler's formula, Rasch's formula, then the slenderness ratio less than 4, it is the short column, and greater than 4, it is the long column. And the fifth unit is design of wall fitting. That means here we are going to study about the course outcome. Unit, the design of footing. So various footings are there. Footing is very important structure in the foundation. So if you study that subject, after the studying the subject, what will be the course of something, you can be able to design the wall footing, isolated footing, and combined footing. Directly I'll go to the subject. So all this I explained in the introduction video. What is concrete? While we are introducing reinforcement in the concrete, what is the purpose of introducing steel in concrete? So the main point is concrete is strong in compression but weak in tension. That's why to overcome this, we are introducing the steel bar in the tensile resistance. So here you can see in this slide the stress strain curve for concrete. So in the x-axis that is strain and the y-axis that is the stress. So how that applying the load on the structure, what will be the stress and strain? The steel bar placed in the tension before the concrete is poured can have very good bond with the concrete both mechanically and physically. After the hardening of concrete, which means that the reinforcing bars become an integral part of the material, with no new combination for both concrete. Because of the bars, the deformation of both concrete and steel that is strained and interacting on the concrete are the same. The initial compression applied to the beam to be fixed in the that it is lost to the Later, the flower pots left, they reinforce concrete. As they spread this concrete, the concrete is not directly used to make small models, uh, for example, flower pot and the board material. Wood. In 1855, Drcse project used painted concrete first time in the building, and 1861 he wrote a book in that he said what is the use of concrete. So the first theory of reinforced concrete was published in 1886 by Ponin. And here you can see why we are introducing these, because it has a high tensile strength, good bond with concrete, nearly same coefficient of expansion of that concrete. So here you can see in this picture what are the different types of steel bar. Steel bar. So this steel rod is varying depending upon the diameter. So it starts from 8 mm to 3 mm. Here you can see the classification of steel bar. So mild steel bar. In that mild steel bar, mainly it is classified into four types: mild steel plain bar, high deformed bar, hard drawn steel wire fabric element, rolled steel even. In the mild steel plain bar, again it is classified into cold worked mild steel bar, hot rolled mild steel bar. And the high yield strength deformed bar, again it is classified into 500, then cold worked deformed bar. What is the cold work? In the cold region can use this bar. Hot rolled deformed bar is very hot, then hard driven steel wire plastic bar is rounded channel. Different steels having the different codes, code lines, and are the functions of reinforcement in our system. So it resists the regime moment is fluctuation like glass, steel, etc. Then it resists the diagonal tension due to shear to increase the load carrying capacity of the column to resist the effects of secondary structure to reduce the shrinkage of concrete to reduce the spiral cracking to prevent the development of wide cracks in concrete due to tensile strain. So reduce all this stress and it reduce the effects of it. Yes, it's the reinforcement function. So in this table you can see grades of concrete. What is this grade? So here, based on the compressive strength of the concrete, so we will prefer the two for the concrete cube 150 mm by 150 mm size. After separation of the cube, we will keep the cube immersed in water during up to 28 days. After 28 days, if you take the cube and if you how much load stand takes that uh, that value says the based on that value the grade of concrete is separate. Here given the M pen that means M stands for here you can see the definition of concrete load M and the number to specify compressive strength of 150 mm size cube which is expressed in units per mm square. Like that, M is 15 and 30 is ordinary concrete and the compressive strength is 10, 15, 20. So which concrete we can say standard concrete means heavy loader structure, we can use this ice chain concrete. Here you can see this part is stress strain curve for reinforcement for mild experience. That is the stress strain curve. If you before going to design structure, you should know about the load. What are the loads activities? So we can say dead load, live load. So what is the dead load? Nothing but the self weight of the concrete. Self weight of the concrete. That means material weight, like this, moving weight. And the construction load settlement is something lack of government temperature changes, etc. Wind load delivery water into consider in electric load, etc. Dead loads are due to the state of the structure as is earlier. Dead load includes the state of walls, floors, even state of walls, floors, beams, columns, etc. And also permanent fixtures present in the structure. Here you can see for different materials, it has a weight, which is given in this table. Part 3. The client will see client PPC can see what is the self rate. This is very important. We will use in this value in the second, third is not slab. We need to find the load calculation. So that time we use this self rate PPC. What is the value and the RPC. So PPC the use basic is 77 kilometers per meter. Live load. What is in the live load? It is load R structure. Live load may be a people, furniture, machinery, equipment. So here you can see a bathroom and toilet, constant human types of building, all types of building. This is office, this is five, this is banking hall, 3 kilometers per meter square. This is recording room, 3 kilometers per meter square. This is hotel, hostel, etc. Library, 4 kilometers per meter square. Wind load, the magnitude of wind pressure what happened is the change the shape and technology of the structure. So we need to consider reduce pressure while preserving the structure. Quick forces. So we take off the ground motion changes nature and forces that lead to way back force. Placement of the level is zero at the base is maximum at the base. Here in this table you can see partial 50% for load. So for a combination of these loads and the limit state of collapse and the limit state of the rigidity and the load value here you can see. And here you can see IS code. This is the code we are going to use this subject IS 2000. So we will cover all the formulas and the design procedures, how to take the reinforcement, how to design the reinforcement, spacing, how much spacing to use, and how much diameter loss we need to take to maintain in the IS 2000. So here you can see cover to regulate IS standard 456, which is a number given, and then it is 20,000. Table 60, 60 partial system. Why we need to design this structure? First, we starting before the integration, what we start is only interpretation. So, reinforce concrete distribution satisfy the concrete criteria. So, we have to design for the adequate safety and thickness and durability. This is not the thing. So, the structure is shared. So, the objective of design flexibility, durability, increase the strength, increase the durability. Then we have design design picture. What we are seeing just without any string like position. That means this is a cube without rod. So here you can see cube with rod. Okay. So the structure will withstand load comes also, it will withstand. If the tensile force to the tensile force will be applied also, it will withstand. Okay. So here you can see the second story building collapse in the Tano Maharashtra. These are of the substandard construction materials. So the faulty design, what happened here? The flyover. Uh, what is the design? What is the objective means to design stability and serviceability? So we need to take consider the CCC and RCC. The objective of design. There are three methods in design the structural however, working shift method, activity method, mistake method. So what is based on legal activity. So here we are assuming the concrete is elastic, but practically it is not possible. But we are assuming the concrete is elastic theory. So it's very complicated. It's practically not possible. So the assumption we are not using it working the system nowadays. We are using only the existing method. It is the advanced method to change. That means working stress method and load method. So here you can see the working stress method ensure adequate safety by suitably restricting the stress in the materials. The assumption of is what are the assumptions for working stress method? So the ratio of each strength of the concrete to the corresponding permissible or working stress is usually called Drcse. So here you can see working stress method how we will design. First we will find out the modular ratio. That means ratio between modular of elastic steel and concrete. Here the factor of safety for working stress method is with respect to strength. Steel 1.8, factor of safety is 1.8 in the working stress method. And the assumption here we are assuming both steel and concrete act together. It is an elastic atom. Major defect in this center is it is only the elastic behavior of the member with a larger percentage of construction steel. So one of the assumption ultimate load. This method is based on the ultimate strength of explosive concrete at ultimate load is 10 suitable for all structures. It increases strength, durability, serviceability of the structure, thereby it reduces the collapse of structure. So here there are two types of structure, state of collapse and limit state of serviceability. So it is this design assumption it is given in IS 456 67. We no need much of this design concept. It is given IS 456. IS 456 is allowed in the exam. You can say that directly to the value from the notebook and you can substitute. The formulas and the procedure it is given in notebook. What is in the characteristic and characteristic characteristic strength and characteristic load. It is defined as strength of material below which not more than 5% are expected to follow. So here characteristic load means it is defined as the load that has 95% probability of not being exceeded in the life of structure. So it withstands the load. Then partial safety factor. So the value and the formula is given in 6 plus 6.4. And here you can see what is the difference between working state method and limit state method. And then here you can see the state, the instability, how it is classified again, and limit state, collapse, how it is classified. So here you can see limit state again it is classified into two types, collapse and serviceability. If you take collapse, increase the strength and stability of structure and a maximum load design load. If you take serviceability, deals with the deflection and cracking under service load, durability under working environment, stability, fire resistance, etc. So structural design is classified two types based on the most critical limited and checked for other limits. So this assumption for limit state of collapse and fracture, it is given to this 4 by 6 class 38. So before, what is the assumption means? We should assume that the section is normal all the time. Line section normal to the axis remains plain before and after bending. Even after bending also, we need to assume that section is normal. Then the maximum strain in concrete at the outermost compression have to take 0.0035. The partial safety value is 1.5 shall be applied. So here you no need to mark up all this given in cases. You can catch your progress for all the exams. So whenever this question is being asked, you can note down from the notebook. So here this diagram is the cross section of the beam. Here you can see there is a neutral axis. It divides the beam into both compression and tension. So the topmost zone is compression and the bottommost is tension zone. And this diagram it shows the stress block and this is the strain block. Diagram, diagram. Lever of it is very important term. Nothing but the arm distance of the couple is known as lever arm distance. The depth of the axis from the maximum compression fiber is called depth of neutral axis and it will be noted as characteristic. It is a formula which will use to design the structure using the limit state method in P by P find out the strength of material. So it's not then the person is a thing. Then 5% only we are expensing that structure will change, not more than the 5%. So here is the grade of concrete. What is the characteristic strength? And for grade of steel, what is the characteristic strength? So if you take 80 250, that is 250 is the characteristic strength. And if you take M15 grade of concrete, 15 is the characteristic of concrete. So what is partial safety factor? When assessing the strength of the structure for the new state of collapse, the values of partial safety factor indicated as 1.15 or 3. Then the design strength is very, very important. It is a strength which has taken based on the characteristic strength of the material and considered important. Here you can see how the beam and slab is taken force before concrete. So these are the rods and the erupts. You can see these rods with the keep alignment. So we are providing the proportional. Similarly, these also we are providing the column, horizontal member, vertical member, and the beam and the so here you can see effective cover. What is the effective cover? What is the clear cover? Clear cover is nothing but CC. It is denoted as CC. Effective cover is clear cover plus optic. So that is bar diagram. So from the here you can see either the ground shape it indicates the rod, then assume it is a rod, and here cover of the rod is from the end to this clear cover, and center of the rod to the topmost edge or bottommost edge or this top. Modular ratio. It is defined as utility modular. Modular ratio is denoted as the formula is Q is divided by Q into sigma P CDC. Sigma P CDC is nothing but the permissible stress of the unit. So here we are going to solve the problem analyzing the rectangular field. There are different types of field: balanced section, under reinforced field, over reinforced. What is the balanced section? So in three cases only we are going to solve this problem. The balanced section, balanced section, and section reached simultaneously before collapse. So both join together and it will collapse. That is the balance system. If you take the under reinforced system, the tension steel reaches the yield strain and load further the load at this concrete features here. Over reinforcing, this tension steel also reaches yield strain and load further than the load at concrete features here and here. So here the formula is very simple. In this diagram, under reinforced system. And this is the formula which we find the tension moment and the method. Over reinforced system. This is what is under reinforced system. Now we are going to types of problems, type definition of moment of resistance of the structure tied to different actual structures in the these then design of given section for activation. Procedure for finding moment of resistance. How this problem was reduced of the data, how we are going to find out the moment of resistance in this method. To determine the depth of the needle axis in the formula X by D, X is the symbol of the needle axis and D is the effective shape. So all this already right. Step 2 is Q equal to Q mapping in the difference to the balance section. If Q greater than the Q mapping, that is the overweight force. If Q is greater than Q mapping, as a ratio, etc. So here is for example for the given. Find the moment of resistance of single force property of 200 mm at 4 and 0 effective force with 3 bar of 50 Newton diagram in the 4 and 50. So here the depth of the needle is given and the dia of T 400 of component is given. First step we need to find the T. How will you find out the T? That means the area of T. So the reinforcement means it will be round shape, so that is circular in shape. Height is per by 4 into number of rods. So here we are getting the answer 603.18 square. After that, we need to find the depth of the metal axis. So all these values is given in the problem. So that is we have in the formula. So what we are getting is Q by D less than Q max by D, so it is under the shape, then directly we are going to subtract moment of resistance. So writing the formula, applying the value, get the value. So here the problem, what all the formulas have to use is mentioned in this slide. So thank you for your patient listening. Please in the next video. In the next video, I am going to start the problem, how to work out, how to calculate the moment of resistance and how to find out the single resistance field and how to design the single resistance field, dubbing the input in the under the input and over the input.